This is video help for problem 10.4. We imagine that we've come along with an RF pulse, a transmit pulse, and tip some spins. We want to actually have, that nice boxcar frequency distribution, and therefore we'll have a sync, or at least an approximate sync, in time for our RF pulse. Imagine we're in the rotating reference frame, and so we're not worrying about, the very, very fast frequency. And the B1, if we didn't have any time dependence, B1 would be just sitting at rest. But we're going to turn it on and off. Now, we're going to turn it on and off, however, with a sync function, but we have to start the sync function at some finite time. We can't let it run forever. We have to have it actually kind of short. And so we'll shape the pulse. We need the full symmetric sync function. We'll shape the pulse, and by the way, whenever I draw these pictures, I always have to remember that there's a sort of a 1/, drop off here, and so that every one of these lobes should be smaller, 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 biggest smaller, 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 and I don't always draw them very carefully. But we're going to imagine we've turned it on here and turned it off there. We've shaped it such that we've got a nice approximation to getting a boxcar in frequency space. Now, in contrast to the previous problem, I'm going to call tau RF the total time that this pulse has been on. And now, I'm also going to assume that all the spins are, for the most part, tipped right at t equals 0 with the big peak here. So before this, no magnetization in the transverse plane. Now I've got magnetization in the transverse plane, maybe still some in the longitudinal, but I've got something in the transverse plane, and it starts to precess, and it precesses in the rotating reference frame because I've got a gradient on. I've got the slice select gradient. I've got a magnetic field, GZ, and so if I started out, let's suppose, the way we usually do it, say we're rotating around the X, and so we end up pointing along Y in the rotating reference frame, the prime frame. And then I'll call that, along Y-axis, I'll call that phi equals 0. So with this guy out, my phase starts to shape up, starts to evolve, and it evolves according to minus gamma G SS Z T, starting my clock at t equals 0 at the center of the RF pulse. There I go. I got my phase. That's 0. Now the phase just after I'm going to turn this off will then be at the time tau RF over 2. And of course, if I want to look at different z's, I just change the z here. And if I'm on the opposite sides, I've got z0 plus or minus delta z over 2 for my z value on the slice that's been excited by that RF pulse. And there's some numbers you can check against in the written homework hints. In part B, I go on to think about adding a rephase. You can think about this as this is kind of like a gradient echo, except I'm not taking, taking data yet. I'm going to lose signal by I tip them here, and they start to dephase. At different z, they're at different phases. They cancel each other. I'm dephasing. But I can rephase if I add another lobe with the gradient that's negative, the sign on the initial slice select gradient, and I can get back to 0 phase again right here, and then start to do my imaging with x and y gradients. How do I do it? Well, you know how the phase goes in general. It is minus gamma z g dt prime integrated, because g may depend upon time. This is area. This guy is the area under the gradient during this time. We start at t equals 0. We've got then, I can divide this up. This essentially is the area here. And what's left, g dt prime, the rephase part, it's the area here. Of course, that'll be a negative area, and that can cancel that positive area. In fact, that has to equal and opposite. Be equal and opposite to that area. And if we have that, then it will be, I'll get back to phi equals 0. And then this problem, I think, is fairly clear. In part C, I wanted to know the total time, but first I had to think of what is TF minus TI? Well, if G rephase is the negative of GSS, what do you think this time is compared to this time? And then the way I had it is, it didn't matter if I had a little time where this gradient was 0 here. Nothing's happening, nothing's changing. The phases, there's no precession, it just gets locked in with the phase that it has because I'm in the rotating reference frame. And then it starts to phase again, but with this minus sign here, it rephases. Well, so what I was thinking is the T total will be equal to, this T total is really defined to be the total tau RF plus this time, well, I left a little blank in here. So the answer that we're kind of looking for is what's the minimum that you need? In other words, if this were not 0 and it just started, this part here just started right here.